Now, like in linear equations, we looked at word problems. Well, we're going to do the same with simultaneous equations. Sometimes there is a sentence there and you have to distract the mathematics from it. Word problems, I've called them, simultaneous word problems. What you should do is you should try to minimize the number of variables. You should use logical variables. It's basically the same process as with linear equations. You end up with two linear equations and then you use the methods just described to solve. Let's have a look. The procedure I've indicated here is to determine the unknown quantities and choose logical letters. You write the equations and you solve the equations. And then, of course, you have to answer the problem using the correct units. Let's stay on the screen and then move on to problem number 1. Probably a very simple one. Yes, it is. A rectangle has a perimeter of 22 meters. The difference between the length and the width is 3 meters. Find the length and the width. Well, here we let L be the length and W be the width. And so I can write those two equations now. I know that the perimeter is 2 lengths plus 2 widths, and that must be 22, and the difference must be 3. See? We write them underneath each other like that. And now I notice that I can't add or subtract to eliminate, so I will multiply the second equation by 2, so I can eliminate. And that's what's done here. 2L plus 2W equals 22, and 2L minus 2W equals 6. On the next screen, that's repeated. I've even drawn a picture there of a rectangle, and we add them up because we want to eliminate W. When you add them up, you get 4L equals 28. From that, of course, we get the length equals 7. And because I know that the length is 3 more than the width, I should be able to tell straight away that the width is 4. But I've substituted the value L equals 7 into this equation. And after some simplification, I get 2W equals 8, from which we get W equals 4. The last thing I have to do is to write down the solution in the correct units, 7 meters by 4 meters. Now we have a look at one more example, and I'm not even going to work it out. I'll just show you how difficult it sometimes is to come up with these equations. The solving is probably the easiest part. Example 2. Here we've got a farmer. He has sheep and emus. He counts 92 heads and 194 legs. How many of each does he have? That's a simultaneous equation problem. Doesn't look like it. Well, 92 heads. Let S be the number of sheep, let E be the number of emus. Now, a sheep has a head, an emu has a head, so if I add, I've done the legs first here. I've looked at the legs first. A sheep has 4 and an emu has 2, so I get 4 lots of S plus 2 lots of E being equal 194, and then of course the S plus the E equals 92 for the heads. And I've said here, put the largest on top because it's easier mathematically. Well, the solution comes to 5 sheep and 87 emus. But that was perhaps not the most important thing. The most important thing, the most difficult part, was to actually put it in equation format.